morning. My name is Professor Dr. Chris Geddes from the University of Maryland. I'm here representing LacriScience LLC today to talk about the LacriPen, which is perhaps the world's smallest handheld portable ophthalmic device, osmometer, that fits in the palm of your hand. I spoke to you about a year ago, and a year ago when I spoke to you, we were in early stage development of the LacriPen. However, this year has probably been our most successful year in the company, where we filed considerably more patents, as I'll talk about a little bit later, but we've actually got to a very late stage development of the LacriPen. It's actually a chassis that has all the optics and electronics inside. We are pretty late stage in our development. The LacriPen works using the principle of surface plasmon resonance. And in a nutshell, a tiny gold film, when light impinges on the underside of it, generates an evanescent field on its top surface. When it's very close to a tear film, that evanescent field is perturbed and a little tiny black line will move as a function of the salt concentration, or effectively the change in the refractive index of the tear film. And that's how we're able to quantitate with very high accuracy osmolarity for dry eye syndrome. We use long wavelength light, near infrared light, which is not harmful, it's very weak, at 855 and 950 nanometers. And the reason we use this long wavelength light is we get very sharp and crisp SPR lines that allow us with very high precision to determine the osmolarity of tears. Here is a slide that shows the chassis of the LacriPen. Basically, the calibrates in air and is ready to go. A physician simply attaches the disposable cap, touches the tear film, and you get a measurement within about 1 second. Our sensor cap is disposable. These little plastic, low-cost injection molded caps clip onto the top of the LacriPen. They have the gold as well as other diagnostic components on the surface, and they actually just touch the tear film. It is one sensor cap per eye, and they're disposable afterwards. The advantage of the LacriPen is that we have a very high resolution of determining osmolarity in tears, unlike other devices that are currently on the market today. So we all know that normal dry eye is around 290 to 304 milliosmoles, with very severe dry eye as high as 329 to about 340 milliosmoles. The LacriPen can actually measure from about 270 to 380 milliosmoles, but we have a precision and an accuracy of around 2 milliosmoles. That allows us, in essence, to determine the difference between normal, mild, moderately dry, and severe dry eye. No other device can do that today. As I said, the accuracy of our pen is around 2 milliosmoles, and we only need about 5 nanoliter of tears from the tear film. So as soon as the LacriPen touches the tear film, we get an instantaneous measurement. The device is highly reliable, it's highly reproducible. We don't need anesthesia when we're doing our measurements. We have non-reflexing tearing when we touch the tear film, which means that our measurements are accurate, they're not perturbed by tearing, and we get an instantaneous readout. How quick is the readout? Within a second. So far I've talked about determination of salt concentration for tear osmolarity, but the LacriPen actually is much, much more. We've been developing over the course of the last year a disposable cap on the end of the LacriPen for MMP9. And we can detect MMP9 down to about 5 nanograms per milliliter. There are devices on the market today that can detect MMP9 as low as 40 nanograms per milliliter. But clearly, that's not sensitive enough to distinguish between the lower levels and the basal levels and the elevated levels of MMP9 for the onset of dry eye. The LacriPen, as I said, has a resolution of around a few nanogram per milliliter with a lower limit of detection around 5 nanograms per milliliter of MMP9. In addition, we're currently working on an MRSA, methicillin-resistant Staph aureus, sensor cap, similar to the MMP9 for the detection of MRSA. But the LacriPen can do much more, as you see in this slide. We potentially think that we can detect adenovirus, herpes zoster, herpes simplex, lactoferrin, as well as tryptase using the LacriPen, all at low cost, all very rapidly, all using the disposable sensor cap. What about our financials? Our manufacturing costs of the LacriPen, actually, even though it's an advanced device, we can manufacture for about $450. We anticipate to sell the LacriPen for about $1,400. So it's not an expensive device for any clinical setting. Our prism sensors cost us about $1.25 to actually manufacture. We're going to sell them for about $650, allowing a physician to make significant profit themselves on the billable for the insurance. Our diagnostics, of course, are a little bit more expensive because they have antibodies on the surface of the tiny gold film. They cost us roughly about $2 to make, and we intend to sell these for about $750, again, allowing significant opportunity for a physician with his billable to make some money on top of that. I think one of the key assets of LacriScience is a very strong and expanding intellectual property portfolio. We have several patents that have issued today. We have several patents that are pending, as well as more recently some IP that's been filed. Our IP position is pretty much most regions of the world today. What about our timeline? Where are we in our timeline? As I said, I think this has been a fantastic year for LacriScience, certainly the most significant with how we've got to this very late stage development of the LacriPen. I think by June 2016, we'll have completed the development of the updated sensor design, our very inexpensive low-cost device. I think by August of 16, we will have finished our basic laboratory and basic clinical testing, both not only for Osmolarity, but both for MMP9 and MRSA as well. In September of 16, we intend to submit our 510K using current market predicates, and then hopefully by December of 16, we think we'll be at mid-stage development in our pre-manufacturing process. I think the message to take home with the LacriPen is the LacriPen threatens to change the way we think about ophthalmic diagnostics today. Basically, we have a portable osmometer and diagnostic device that literally fits in the palm of your hand. Thank you.